हेलो यस डियर स्टूडेंट्स, कैसे हैं आप लोग? होप यू विल बी फाइन। उम्मीद करता हूँ आप लोग काफ़ी अच्छे से होंगे, है ना? उम्मीद करता हूँ आप लोग काफ़ी अच्छे से होंगे, राइट? होप यू विल बी फाइन। गुड मॉर्निंग टू ऑल ऑफ यू, 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 गुड मॉर्निंग टू ऑल ऑफ यू। यस, गुड मॉर्निंग टू ऑल ऑफ यू। काफ़ी अच्छे से। गुड मॉर्निंग टू ऑल ऑफ यू, गुड मॉर्निंग टू ऑल ऑफ यू। यस, स्ट्रीम चल रहा है। जी जी जी, तो उम्मीद करता हूँ आप लोग को चीज़ें क्लियर हैं, ऑडिबल हैं, सारी चीज़ें हैं। तो जैसे कि वी हैव प्रॉमिस्ड फॉर टुडे दैट वी आर गोइंग टू स्टार्ट दिस मैथमेटिकल फिजिक्स एवरी दिस थर्सडे। आई थिंक टुडे इज थर्सडे। Every Thursday we are going to have a session for mathematical physics at 10 a.m. Is it clear or not? So the same thing we are going to do over here, that mathematical physics we are going to start over here. In today's lecture, actually, I'll be going to discuss. In today's lecture, actually, I'll be going to discuss the entire syllabus portion of mathematical physics, so that you will be understanding in a very better manner that how the subject is, what is the importance of the subject is, and what all the key role of this subject in understanding all other subjects. Hope you are getting the idea. Hope you are getting the overview what I'm going to discuss over here. Is it clear or not? So that is the thing what we are going to discuss over here. So I'm starting with the syllabus. Hope you are all are everyone will be fine. Is it clear? And in a mood to understand the subject. Is everything clear to all of you? Is my voice is audible? 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 Yeah, I hope everyone is listening in a very better manner. So the main agenda of today's lecture is to make you to understand mathematical physics in a very better manner. Not like that the others classes are going on like simple topics like we are discussing. Basically, I'm going to deal here with the advanced version of the subject. Clear है यहाँ पर advanced topic of the subject. That is very very important for the examination point of view for once you are going to appear for CSIR net examination. Clear, and I hope this examination will be in most probably June July session as per the notification came in November month that CSIR will be going to conduct 3 examinations this year in 2022, because last time one lag was there. So I hope you are getting the idea what I want to explain over here is clear. So this mathematical physics session will be every week, Thursday. Advanced topics will be covered strictly to the examination point of view. I hope you will be going to enjoy the session. Is it clear or not? So I am going to start with the syllabus which has been given in front of you by the CSIR. So let us proceed with this. Is it clear or not? So we are going to start with this syllabus pattern. What does the syllabus states that, and how this is very much helpful for the examination. See, once you are going to start preparation, for any examination, once you are going to start preparation for any examination, syllabus should be in front of you. Syllabus gives the overall boundary, overall region, how much area you have to cover, how much region you have to cover. That is very, very important for the examination point of view. Once you don't know syllabus, you are simply preparing for the examination, that will not work out. If you are preparing for the whole year, for 2 year, for 3 year, simply preparation will not help you out. Simply preparation will not benefit you out. Is it clear or not? So my opinion, what I want to state you is, what I want to discuss with you is, you must be very much comfortable, you must be very much clear with the syllabus, so that syllabus may help you a lot. Is it clear or not? So that you can very easily understand, is teacher is going out of the region, or teacher is strictly within the region of the examination required. Is it clear or not? So the syllabus, what I'm going to start with is, for mathematical physics, physics preparation, if you try to understand, as per CSIR, syllabus has been divided. Syllabus of mathematical physics has been divided in two parts. One is nothing but simply a core part, another is nothing but simply advanced part. As per CSIR syllabus, you can very easily understand. Is it clear or not? That's what I'm discussing with you. Is it clear? You try to understand. See this. This is what the advanced part, what we are discussing over here. See, this is the advanced part. This is the advanced part. Try to see this. This is the advanced part. And this is what also the mathematical physics. Is it clear or not? So as per CSIR, entire mathematical physics has been divided into two parts. One is nothing but simply a core part. If you deal with core part, another is advanced part. Is it clear or not? And from this part, every year you can find 2 to 3 questions. Is it clear or not? Minimum 2 to 3 questions will be there, and rest questions will be from the core part. Is it clear or not? Mainly students feel uncomfortable in the advanced part. Is it clear? They feel uncomfortable in the advanced part. Is it clear or not? So basically our motive, our focus will be to help you out in the advanced part of the representation. Is it clear or not? So that you can be very easily be able to understand the subject. You can very easily understand the essence of the examination. Is it clear? Hope you are getting the idea. Hope you are getting the idea. Is it clear? Everyone is understanding, I think, the syllabus. Is it clear or not? What I have told up to this time, as per CSIR, how the syllabus has been divided. One is nothing but simply a core part, another is nothing but simply an advanced part. How to deal with the core part, how to deal with the advanced part, that we will discuss now itself. Is it clear or not? So now we are in a mood to proceed further, how to discuss with the core part and to deal with the advanced part. Now, see. So first of all, I'm starting with the core part. See, I'm discussing with the core part, how to deal with the core part that I want to discuss over here. Is it clear or not? See, the syllabus starts from here. This is what the dimensional analysis. One is the dimensional analysis. Leave this topic. And here, this is the vector algebra and vector calculus. Clear? Here it is nothing but simply linear algebra, and linear algebra is up to here, up to eigenvectors. Is it clear or not? Dimensional analysis is an independent topic. From there, from next, you have to deal with vector algebra as well as vector calculus. Then you have to deal with the linear and ordinary differential equation of first order and second order. And this topic, I hope many, almost all students have studied few methods in class 12th itself. Clear? Then some BSc, then some MSc. But we have to come over and above that. Is it clear or not? Because as per CSIR, there is some standard. If there is some standard, then you have to touch that standard. Clear? Question will be from this syllabus only, but it will not be like 12th class question. It will not be like BSc type question or simple questions like MSc. There is some standard, there is some concept that you have to apply, and after applying that concept, you have to deal with. Clear है यहाँ पर बात समझ में आया नहीं समझ में? तो you have to deal this type of questions as per examination point of view. Is it clear now? Further, special functions. Special functions. In special functions, see, in special function, it is also differential equation part only. It is also differential equation part only. Clear? This topic also belongs to differential equation, but this is a special topic. A special topic means differential equation should be homogeneous. Homogeneous. What is the meaning of homogeneous? For example, I am writing a differential equation. D square y upon it is nothing but simply dx square plus 2 dy upon it is nothing but dx plus 3y is equal to 4x. Say for example, is this a homogeneous differential equation? No. Here, right side is not is equal to 0. Is it clear or not? If right side is equal to 0, then it will be an homogeneous. Is it clear? So these all differential equations we have to deal with. Homogeneous, right side will be equal to 0. Is it clear? Or एक example, the example what I have taken of an homogeneous differential equation. If right side is equal to 0, there is no function, then this will be an homogeneous differential equation. But here, if some function of x there, then this type of differential equation is non-homogeneous differential equation. There are 4 examples we have to discuss: Hermite, Bessel, Legendre, Legendre, and all these differential equations it can be asked for nth order also. Clear है यहाँ पर बात समझ में? Nth order, d to the power n, यहाँ पर dx to the power n, you have to deal with. Is it clear or not? आगे चलते हैं. Now let us proceed further. Now let us proceed further. See. So hope you got the idea. Vector algebra and vector calculus, these are the simple topic. No need to bother about that. Very, very simple. Linear algebra basically deal with the matrices and some advanced topic like that vector dependence that we will deal here itself. And from that vector dependence, linear independent, dependent, this type of questions, conceptual questions are asking in the examination. Is it clear or not? So that also we are going to discuss over here. Is it clear? Acha. Total weightage of mathematical is approximately, you can assume that 35 to 45 marks. Is it clear or not? And this is the key part from where a candidate can easily decide where his selection is there or the rejection is there. Clear hai par? Because this part is almost dealt by every candidate, every aspirant in their graduation, in their masters. So almost everyone try to achieve a big hand over this topic. Clear hai par? But it's not compulsory, it's not necessary that everyone can have a big hand. Big hand means can achieve a good mark in this topic. Clear? Because totally conceptual part. Is it clear? Or once you have a good concept, then you can very easily understand this. Is it clear? Concepts are very, very important. Entire thing is conceptual only. Is it clear? Actually, I'm opening one another window or another page so that you can very easily understand the basics of this topic. Is it clear or not? That's why I'm opening another page so that I can explain you in a very well manner. Now, the next topic, see here. Fourier series, Fourier transform and Laplace transform. See, this is what the topic here written as per the syllabus. That is Fourier series, Fourier transform and Laplace. What is the basic difference between Fourier series, Fourier transform and Laplace transform? Laplace transform. Before explaining this, I have never explained anything about this linear algebra. I've never explained anything about the linear algebra. I want to explain something about the linear algebra. See, linear algebra. Few things I want to explain you about the linear algebra. See, if you want to understand this physically, in linear algebra, we have to discuss matrices, we have to discuss Cayley-Hamilton equation. These all things I hope you have heard the names. Though I don't know whether you know the picture behind matrices, linear algebra, that I don't know. But I hope you have heard this name. Now, for example, if I discuss with the matrices, say for example, this is 3 by 3 matrices. 3 by 3 matrices. 1, 2, 3, 4, 5, 6, 7, 8, 9. Say this is a matrix of the order 3 by 2. What is this? What is this? What is this? This is a matrix. Everyone, I hope know this. This is a matrix. But but what actually inside? One number or many number? बताइए जरा सा. There is only one number or many numbers are present? Many numbers are present. Is it clear or not? Don't feel this as a number. Feel this as an information. Clear है? You can try to understand this as an information. Clear है यहाँ पर? So in this, don't feel this is a matrix. Feel this is a packet. Clear है? This bracket is nothing but simply called as a packet. Is it clear or not? And in this packet, not only single information is there, many information is there. Clear है यहाँ पर बात समझ में? And for example, very sensitive informations are there in this. Sensitive informations are there in this, and you want to transfer this information from one place to another. Clear है? But say this information is there. I want to transfer from here to here. Clear है यहाँ पर बात समझ? If I want to transfer this information from this source to this destination, and if it is a highly important information, then this information can be hacked. Is it clear or not? Anyone can steal this information. Is it clear or not? If someone can steal this information, so I need to preserve this information. Clear है? But if you want to preserve this information, see, for example, this was the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Clear है? यहाँ पर बात समझ में? This is what the representation. If anyone can steal this information, so and this information is highly important for me, I need to preserve or protect my information so that anyone can't acquire this information. So what I will do is I'll shift this like this to here, 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 like that. Shifting is there. Shifting is nothing but simply some rotation. If I make this rotation by a 45-degree like that, entire information will be rotated. So if anyone gets the information also, if I changes some information by shifting or something other method, that shifting I only know. No one can decode that. It means if anyone get my information, then he will not get the entire thing. He will get some disturbed information. So he need to do some extra effort to get the original information. That will be very difficult for the thief or who has theft my information. But like by that, I can protect my information. And this one of the method for protection of information is nothing but simply called as rotation of matrix. Clear है? Rotation of matrix. I hope you are getting the idea. Is it clear or not? So rotation of matrix is nothing but it is a method to protect our information. It is a method to protect our information from being it's going to theft. Is it clear or not? This is what the rotation of matrix. I hope you got the idea. You need to study the subject by this method, not by that method. What you are studying in simply matrix addition, matrix subtraction, matrix multiplication. Nobody is going to ask you. You must be able to study in a physical significance, physical manner. You must understand the physical significance of the subject. Is it clear or not? Now, I hope everyone is getting the idea. I hope everyone is getting the logic. Clear? No one is feeling any problem over this subject. Is it clear or not? What I told you, the concept that is very, very important. Now, so once you discuss the syllabus, so the next part is nothing but simply this part. This is Fourier series, Fourier transform, and Laplace transform. Acha, I have never told you anything about differential equations. Say for example, this is d square y upon dx square plus 2 dy upon dx plus 3y is equal to 4x. Maybe it is a homogeneous, maybe non-homogeneous. I'm not bothered about. Is it clear or not? But though this is a non-homogeneous differential equation, because right side not is equal to 0, right side not is equal to 0. But still, if right side 0 also, no problem. I need to solve this differential equation. That's my concern. Is it clear or not? Now, see this. What is the use of this differential equation? Use of this differential equation. Any differential, not this differential equation, any differential equation. What is the use of this differential equation that I need to illustrate? First of all, finally, a question will be like that. Calculate the solution. Solution, if I want to calculate, then finally solution will be like that. Y is equal to something, 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 C1, C2, like that. I'm not interested in the solution. Is it clear? But solution will be like that. Acha, solution means final. Is it clear or not? And final means that is required. Acha, if you are going to any lab and if you are working on any instrument, finally required thing is nothing but simply output. Output. So y is also called as output of this differential equation. Clear है यहाँ पर बात समझ में आया? And this x is nothing but simply called as input. Is it clear or not? So differential equation nothing but simply comprises of output and input. For example, dx upon dt is the differential equation form. Then x will be the output, t will be the input. It will be like that. I hope you are getting the idea. Is it clear or not? Try to understand like that. Feel the essence of the subject. Is it clear or not? Once you understand the essence of the subject, once you understand the feel of the subject, then proceeding forward will be very simple. If you don't understand, don't feel the subject, simply mugging up, that will not be better for you. That will not be going to be good for you. Is it clear or not? So what I need, we have to discuss further part also. But before proceeding further, I want to just inform you that how the schedule we have decided for this entire subject, that I'm going to tell you. See this, how we will be going to deal with this subject. Every Thursday this session will be there. Is it clear or not? Every Tuesday electronics session will be there, same time morning, that is nothing but simply 10 a.m. Is it clear or not? So please try to be focused while we are discussing the subject. That will be very much better for you. Is it clear or not? Now further, so I told you something about differential equation. I told you something about matrices. I have never told you something about vector algebra, because that's very simple topic. In this I'll deal you, but later on. Clear? Now the next part what I'm going to deal with, Fourier series, Fourier transform, Laplace transform. Clear? Now names are looking like that, Fourier, but the thing is different. Is it clear or not? बात समझ में आया? So what we need to illustrate you, what we need to tell you is there are some differences between Fourier series and Fourier transform and Laplace transform. What you need to do is you need to understand that these two, Fourier transform and Laplace transform, are almost same. What you need to deal with, that what you need to understand is, what you need to keep in your mind is Fourier transform and Laplace transform are almost same. That you need to remember. Fourier series is entirely a different thing. Fourier series is entirely a different thing. Is it clear or not? This you need to remember. Is it clear? Fourier, the use almost same means the use of Fourier transform and Laplace transform are almost same, but the use of Fourier series is entirely different. Now, what is the use of this? The use of Fourier series is nothing but simply representation. For example, sin x, you can write a series something plus x square, x cube, like that. Simply cos x plus x square plus x cube, like that. Similarly, log x, you can write something, a series representation, like that. I'm not interested in series representation, but what this series represents, this represents sin x. For example, if you write another series, that represents cos x. If you write another series, that represents log x. If you write another series, it will represent e की power x. Is it clear or not? So series is nothing but simply a representation of something. Is it clear or not? I hope you are getting the idea. What is the use of series? Generally, I am asking, what is the use of series? Series is nothing but simply used to represent something. Series is nothing but simply used to represent something. Is it clear or not? Now come to the Fourier series. Fourier series is also a representation of something. Then what is the thing? If you write this as the wave, if you write this as the wave, if you write this as your wave, all these are periodic because this triangle is also repeating, this square is also repeating. If you show this sine wave type structure is also repeating. Clear है यहाँ पर? If repeating means periodic, So this Fourier series or this series is used to represent something. That something is nothing but simply a periodic function. Is it clear or not? So any periodic function, any periodic function, periodic function can be represented by Fourier series. Is it clear or not? This is what the representation, this is what the use of Fourier series. Hope you are getting the idea. Is it clear or not? So what is the use of, if anyone asks what is the use of Fourier series, then you can very easily define that Fourier series is used to represent a periodic function. Is it clear or not? Try to remember this. Try to keep it in your mind. Is it clear? Once you keep it in your mind, then very easily you can keep a picture of the question as per your examination. Is it clear or not? Is it clear? Now let us proceed further. Now see, so Fourier series part is done. Fourier series part is done. It is series nothing but simply to represent. If anyone asks like that, tell like that. It is used to represent. What do you want to represent? Something. For example, that series, one series represents e to the power x, another series represents cos x, another series represents sin x. So Fourier series represents periodic function. Periodic function. Try to remember like that. Is it clear or not? Like this, you need to represent something. Is it clear? That periodic function may be a square wave, that periodic function may be a sine wave, that periodic function may be a triangular wave, that periodic function may be a sine type wave. Clear है यहाँ पर बात समझ में? So I hope you are getting the logic of the Fourier series. So but the function should be any function or periodic function. That is very, very important for the conceptual point of view. Is it clear? Now let us see Fourier transform and Laplace transform. Fourier transform and Laplace transform. See the use of Fourier transform and Laplace transform. What is the use of that Fourier transform and Laplace transform? That we need to discuss. See that the use of Fourier transform and Laplace transform. I'll be telling you what is the use of Fourier transform and Laplace transform. You must be able to understand the use first. Once you understand the use of thing, then you can be able to apply the thing. Is it clear? Once you don't know the use, simply calculating. We have many time interaction. We have done many time interaction with the students, those who are appearing the examination for CSIR from past 2010. And we are seeing that students are appearing and they are attempting the question. They are simply solving, but they are not finally getting the answer matched with the options what CSIR is giving in the question paper. Many people are getting wrong answer also. But this topic what I am writing here, this Fourier transform, Laplace transform, as well as if you see this Fourier series, and these are short questions for the examination point of view. What I need to tell you is before even solving the question, without touching the pen and paper, you can be able to know the basic pattern of your final answer. It means this is the topic where you can very easily conclude that your final answer will be this type. If you're not getting the final answer will be this type, then it means you are doing some mistake. This is the beauty of this topic. Is it clear or not? Even if you are getting slight deviation from your final answer, you can avoid that. Is it clear or not? But the students are like that type. They are solving, and they are getting the wrong answer, and even they don't know my answer is wrong also. So you need to study like that. So that you must be able to check your answer, check your pattern of answer even before solving the whole. Is it clear or not? So this is what the representation that I need to discuss over here now. So what is the use of Fourier transform and Laplace transform that I need to discuss over here is use is same. That is 100% true. दोनों का the use of both the transforms The use of both the transforms are same, also same. That is 100% true. No issue. See, a lot of differences are there in the Fourier transform and Laplace transform. First of all, don't think like that why we are studying, but I will tell what is the basic use of Fourier transform and Laplace transform. That I am telling you, the use is same. Is it clear or not? But there must be some difference, so that after Fourier transform we will be discussing Laplace transform, because first Apple 6s phone has 6 Apple 6 phone has come launched in the market. After that 6s came, 7, 7, 8, 9, 10, like that series is coming. Definitely some disadvantage, some lackings will be there in the previous version, so that the latest version of mobile phones are launching in the market. Definitely here also some issues will be there in the Fourier transform, so that Laplace transform has been launched in the market. So that we need to discuss over here. Is it clear or not? But still the use of both the methods are same. That I need to discuss with you. Is it clear or not? That I need to discuss with you is uh, same. Now, let us proceed further. Laplace, Fourier. Laplace as well as Fourier. That we need to discuss here. Is it clear or not? Now, we need to discuss both are transform. Both are transform. Series we have done. Series is nothing but simply to represent, no other use. Acha, we have seen one differential equation, d square y upon it is nothing but simply dx square plus 2y dy upon it is nothing but simply dx plus 2 dy by dx, leave this y also, plus 3y is equal to 4x. What is the use of this differential equation? To calculate the solution. Solution means y here, y we want to calculate, and final solution is nothing but simply called as output. That also we have discussed. So differential equation, the purpose of differential equation is nothing but simply to calculate the solution. Solution is also called as output. Is it clear or not? The use of Fourier transform and Laplace transform, the use of Fourier transform and Laplace transform, use of Fourier transform and Laplace transform is also used for the calculation of solution, or sometimes it is also called as output. Is it clear or not? That is the thing what I need to discuss over here. Is it clear? The use of if you want to use Fourier transform, if you want to use Laplace transform, if you want to use any there are a number of transforms are there in the market, but we have in syllabus only Fourier transform as well as Laplace transform. So we are discussing only Fourier transform and Laplace transform. But what I need to discuss with you is, but I need to discuss with you is, but what I need to discuss with you is both the transforms, both the transforms are having same use. That is, what is the purpose of differential equation? Same purpose is there for the Laplace transform as well as Fourier transform. Differential equation is used to calculate the solution. Why? Why? This is the y. This y. This y. This y. So same use of Laplace transform as well as Fourier transform is there. That is, they also used to calculate y. Y means solution itself. Clear है यहाँ पर बात समझ में? Now further, if you need to discuss Fourier transform as well as Laplace transform, if you need to discuss these two transforms, the issue is, for example, if the differential equation is like that, try to see here, d square y upon it is nothing but simply dx square plus 2 dy upon it is nothing but dx plus 3y equal to e की power minus x. One example I am writing. Any function of x, e की power minus x. D square y upon dx square plus 2 dy upon it is nothing but simply dx plus 3y equal to e की power x, e to the power x. This is Laplace and this is Fourier. Is it clear? What is the difference between the two differential equations? That I need to ask you. I want to ask, what is the basic differential? What is the basic difference between the two differential equations? Both the differential equations are almost same. Both the differential equations are almost same. No difference is there. only right hand side is having some difference. One is nothing but simply e की power minus x, another is nothing but simply e की power plus x. Hope you are getting the logic. Is it clear or not? Both the differential equations are almost same, only right side is some difference. If I want to plot the graph of right side, e की power minus x, if you want to plot this is the first graph, second graph is for e की power plus x. This is e की power plus x, this is e to the power minus x. If I want to plot the graph, of the two things, now if you see e to the power minus x exponentially decreasing, graph will be like that. E to the power plus x exponentially increasing, graph will be like that. Is it clear or not? Now, if you calculate the area under this curve, area means integration, minus infinity to plus infinity, f of x dx. This is what the calculation of area. Clear hai yahan par? So if this is e, you can calculate minus infinity to plus infinity, e to the power plus x. This is what the graph for e to the power plus x dx. If you calculate, this will be infinite. Area is infinite. Is it clear or not? Now, if you go for this graph, minus infinity to plus infinity, e to the power minus x dx, whatever be the function, you have to integrate. Here my function is e to the power minus x, I am integrating this. Here the function is e to the power plus x, I am integrating here. Is it clear or not? This area will not be infinite, but this will be finite. What the conclusion comes from the two graph? Exponentially falling function or decreasing function is having a finite area under the curve. Rising function, expanding function, going higher function is having infinite area under the curve. Is it clear or not? Those functions whose area under the curve is infinite, whose area under the curve is finite, try to understand. Those functions whose area under the curve is finite can be solved by Fourier series. Can be solved by, so not, sorry. Try to understand. What I need to illustrate here is two areas are there. One is finite area, another is infinite area. Those functions whose area under the curve is finite, can be solved by Fourier transform, not series, but by Fourier transform. Is it clear or not? Those functions whose area under the curve is infinite can be solved by Laplace transform. This is what the basic difference between Fourier transform and Laplace transform. For example, a function x, whether we have to use Fourier transform or Laplace transform. See this graph. This is the graph like that, and this is the increasing function. Area under the curve will be infinite. You have to use Laplace transform. Is it clear or not? I hope you are getting the idea. Is it clear or not? So you must be able to understand the basic picture, basic overview, so that very easily you can understand like that. Is it clear or not? Hope you are getting the idea. I hope you are getting the idea. Very simple representation, very simple notation. But you must be comfortable. Is it clear? That is our target. Is it clear? Now, so I hope you got these topics also. You have understood these topics also. Fourier series, Fourier transform, everything you have got. Now, let us proceed. Now come to the elements of complex analysis. This entire up to here, this is what the complex analysis. Elements of complex analysis. You have to discuss analytic function. You have to discuss Taylor series. You have to discuss Laurent series. You have to discuss pole. You have to discuss residue. You have to discuss evaluation of integral. Whatever written in front of you, the basic thing behind is whatever written here, whatever be written over here, try to understand. Whatever be written over here, see, 1 minute, one error has been occurred. No problem. It will automatically be eliminated. See, whatever written here, for example, pole written here, singularities, singular points written over here, or something else, whatever be written here, analytic function written over here, anything written, Taylor series written here, Lorentz series written here, analytic function written here, evaluation of written integrals written over here in the syllabus. Leave all the things. What you have to do from the basic point of view is, what you have to do from the basic point of view is, what you have to do from the basic point is complicated integrations to be solved, in an easy manner, that is the logic behind complex analysis. Is it clear or not? So complex means you have to make simple. Is it clear or not? Complicated integrations you have to solve in an easiest manner. This was the basic thing which has been behind the curtain, that you have to solve complicated integrations by using simple techniques. Is it clear or not? This was the basic behind that. Now what you need to discuss mainly over here is, what you have to mainly discuss over here is analytic or not. Is it clear? Analytic means whose analysis can be done. This is what the meaning of analytic. Is it clear or not? Now, for example, 1 upon x minus 2 is there. 1 upon x minus 2 is there. Say this is a function of f of x. Whether this function is analytic or not. Is it clear or not? So denominator, always analytic can be checked from the denominator. That is what the logic behind this. Is it clear or not? Take this x minus 2, equate it to 0, x equal to 2. Take this 2 and substitute here. So 1 by 2 minus 2, x is equal to 2. Put the value of x is equal to 2. 2 minus 2, that is 1 upon 0. That is equal to infinite. If any function, say this is a function f of x, any function f of x at any point, for example, here this point is x is equal to 2, at any point reaches to infinity. Say this has been reached to infinity. Is it clear or not? 2 minus 2, 0, 1 upon 0, infinity. Then that function is nothing but simply called as a non-analytic function. Is it clear or not? I hope you got the idea. Is it clear? At that point, for example, x is equal to 2 is the point where function becomes infinity. Then that function is nothing but simply called as a non-analytic function. Say for example, if I ask you a function that is nothing but simply called as delta x. If you see the graph of delta x, this is what the graph of the delta x, or you can represent like that. This is the graph of the delta x. Arrow represents it's going up to infinity at x is equal to 0. So delta x is also called as a non-analytic function. Is it clear? But why we are studying this delta x function? Because it simplifies bigger calculations. That's why we are discussing Dirac delta function. Hope you got the idea. The use of the Dirac delta function. Dirac delta function can be very easily used to simplify those calculations which need 5 pages, 10 pages can be solved within 2 lines. Is it clear or not? This is what the use of Dirac delta function. This is what the use of Dirac delta function. Is it clear or not? This is what the use of Dirac delta function that we need to discuss over here. Is it clear or not? Very simple notation, very simple representation. Hope you got the idea. Is it clear or not? So complex analysis means making the thing simple, making the thing easier. I hope everyone is getting. Now see the next topic. Now see the next topic. this elementary probability theory. Probability, if you see this topic, probability, the probability is the basic part. After that, probability theories are there. In those theories, variable is there, binomial distribution, Poisson distribution, normal distributions are there. Is it clear or not? Some advanced version of probability. Is probability, there are two questions you can expect in the examination. The very first question in the probability theory, will be a basic question, calculate the probability like that so and so question will be there. That will be of 3.5 marks, and that you are discussing from your 12th basic. Is it clear? We need to discuss basically theories associated with the probability. In those theories, we need to discuss random variables. See, if you want to, there are two things you need to remember. Two things you need to remember. That's what I'm interested over here. One is nothing but theorem, and another is nothing but simply distribution. I'm writing in another page. Theorem and distribution. Theorems are basically used to calculate. Theorems are basically used to calculate probability. Is it clear or not? Probability. Theorems are basically used to calculate probability. For example, in our syllabus, binomial theorem is there, Poisson theorem is there to calculate the probability. That's what written over here. Try to see this. See this. Theory, in theory here, if you see the theory part, elementary probability theory. In these theories, we have to discuss theorem, binomial theorem, Poisson theorem. Those are basics. But after theorem, we have to discuss some advanced part. That is nothing but called as distribution. Is it clear or not? Binomial distribution, Poisson distribution, normal distribution. These are the advanced versions of the probability. Clear है यहाँ पर बात समझ में आया नहीं समझ में? तो that thing we need to discuss over here. Is it clear? So I hope you are getting the idea. You are getting the logic over here. Is it clear? Is it clear to all of you? Is it clear to all of you? I hope the rate of internet is slow. That's why some lagging is there in the video. No problem. From next class onwards, we will be keeping this in mind, and you will be finding no problem while the live class at the YouTube. Is it clear? So distribution is nothing but simply the advanced version. Theorem is nothing but basic version to calculate the probability. Here, some not only probability, here some advanced things we are going to calculate over this distribution. Is it clear or not? Sticks you can assume like that. Stats. Is it clear or not? That we need to discuss over here. For example, mean, variance, deviation, like that we need to discuss over here. Now, see the advanced part of this. Here, green function written here. Green function. The use of green function, I'm going to tell you. Green's function. Very important. Very important. Use of Green's function is to solve non-homogeneous differential equation. We have a lot of methods to solve the non-homogeneous differential equation like that. We have seen in the previous differential equation methods also, Laplace, Fourier, like that. A lot of methods are there. Then what is the use of this Green's function? Green's function basically use Green's function basically use Dirac delta to solve the differential equation. Is it clear or not? And I've told you now only that Dirac delta simplifies the calculation. Is it clear or not? This is what the use of the Green's function, a method given by Green's, so that you can very easily solve the complicated differential equation within 2 to 3 lines. Is it clear or not? This is what the use of the Green's function. I hope everyone got the idea. Where we can apply the Green's function? Non-homogeneous differential equation. It means if you write any differential equation equal to, right side will not be 0. Is it clear or not? In that differential equation, you are going to use Green's function. Hope you got the idea. Is it clear? Hope you got the idea. Is it clear? Now, partial differential equation. See, partial differential equation, this Laplace wave, heat equation, 2 dimension, 3 dimension. This is dealt in electromagnetic theory, because electromagnetic theory is one of the that portion of CSIR net syllabus. It can't be without wave and heat. So we are doing this part in that also, that here. Now, elementary elements of computational techniques: root of a function, interpolation, extrapolation, integration by trapezoidal, Simpson. Yeah, what is the use of this that I'm going to tell you? See this. What is the use of this that I need to tell you? Please try to understand. If you want to solve, see, definite integrals. Definite integral means integrals having limit -2 to 2, -3 to 4, like that. Limits are there. Those integrals are called as definite integrals, and with some approximation, with some approximation. Then these techniques are used. For example, Simpson's rule, trapezoidal rule, Runge-Kutta method. Though it's not mentioned here, also Runge-Kutta is also mentioned. So these all are the methods that we need to use. Finite difference method, those we are going to use for the solution of integration. Is it clear or not? Definite integrals. Tensor is especially related to vector itself, but it is the advanced version of the vector that we are going to discuss over here. Tensors, most of the leave this topic, but sometimes if the question comes, that question is very simple from the tensor that we will discuss. Group theory, basically up to this we have seen questions are almost very simple. Calculate, check the whether it is forming a group or not, it is the part of a group or not, like this type of questions are there. But in syllabus mentioned here SU2, SO3, here one S is missing, SO bracket 3. 2 means order 2 of the matrix, O means 3 means order 3 of the matrix, 3 by 3 matrix, 2 by 2 matrix. SU means special unitary matrix, SO means special orthogonal matrix. So these two basically we are going to discuss in examination. If question comes now, then this question will be from SU2 and SO3. Why? Because this is the advanced and it is mentioned in the syllabus. So we have to deal with this part here. Is it clear or not? I hope you got the idea. I hope you got the logic. You got the syllabus overview. Every Tuesday, class will be there for mathematical physics, YouTube live, and without any lagging of this internet. So please be at the right time at 10 a.m. We will be proceeding. That recorded version will also be there on the YouTube. You can watch that also, or you can watch the live version also. You can ask the complicated even doubts also. Is it clear or not? So I hope you got the idea. I hope you understand the basic overview of the syllabus. Everything is clear, I think. If anything, you can comment in the comment section, or you can WhatsApp at 8447 615 753